Okay, so synthetic division, reviewing everything we were going over yesterday. This one's actually going to kind of work backwards for what we're doing today. That for this part of it, we're going to write equations. It's the opposite. This time they're going to give you the solutions, and they're going to ask you to find out what the equation would be with these given solutions for this part. Okay, so what we'll do, I'll just show the one out here first. Throw out an easy one, and we'll make it just a little bit tougher as we go along. Okay, so this is basically like Jeopardy math. This time you got the answers. You got to tell me what the question was with it. So probably what they'll do is they'll tell you, all right, the very first thing is we're going to have two solutions. We're going to have x equals -2. Oh, put up here. X equals 2 and x equals -5. All right, so as you're solving this one, we're going to go ahead and write out what the answers are first. We've got x equals 2. You got x equals -5. And so this one, we're going to do everything basically in reverse. That if you almost could like put this at the bottom, we're going to kind of work our way backwards and kind of go at the top. That if they give you solutions, the very first thing that you're going to do is that you should have taken whatever this number was and moved it back over here so it equaled 0. So this one would be x minus 2. For this one, we would add 5 to both sides. So that's x plus 5 equal to 0. And then usually if we were doing this before, this is where these two things were kind of separate. You'd bring those two things back together in one expression or one side of the equation. And then from there, we get through the full method. So we're going to do x times x times 5. So we got x squared plus 5x. We got -2x and a -10. So one equation we've got would be something like that. Okay, so if you're given solutions, basically get the solution, get that variable, the constant back on the side with the variable. So you've got it equal to 0. Take those two expressions, pull them together, multiply them out, and then from there, just kind of go through and do the full method. Now, and again, this is not like the only possible one it could be, but they say basically kind of make it the easiest one because it could be that there may have been that greatest common factor. That if we multiplied everything by 2, it could have been 2x squared plus 6x minus 20 could be an equation. Because if you factored out the 2, you know, the 2, if you set 2 equal to 0 because it's a common factor, that doesn't do anything. But they say, for the most part, don't worry about any kind of common factor that you could have taken out. So we're just going to assume that you didn't. There's no multiples of 3 or 4 or anything like that when it comes out to it. Okay, so again, it's Jeopardy math. You got the answers now. You got to tell me what the question was. Okay, now the one thing that kind of goes with this one, here's a couple of details we got to add in with this part. Because we know we're going to get from the questions we're doing with the synthetic division, some of the ones we did just before this. We know we're going to get some complex or some imaginary solutions or radical solutions. So the complex solutions and the radical solutions those are going to occur in conjugate pairs. And remember, if you forgot what conjugate is, that's basically where you're going to change plus or minus, basically what it comes down to. If you've got one that's a plus solution, the other one's going to be a minus solution. Because if we're getting it from the complex or the radical solutions, that's where we're going to be getting those from the quadratic formula. And if you use the quadratic formula, you always get this plus or minus in the middle. So that's always going to give you the conjugate pairs answers when you go through these. So that's kind of why that's always going to work out that way, because you're going to get these things from using the quadratic formula. And because of the plus and minus, that means you're always going to be conjugate answers there. Basically, which means this. We'll make a quick little T-chart here. Now, and some of the questions will be really easy in the homework because some of the questions, it's going to be just as simple as this. They're going to give you a solution, something like 2 minus 3i, and they're going to ask you, all right, name another solution to this equation, or name another solution. Well, if it's 2 minus 3i, conjugate's going to be just 2 plus 3i. And some of it's going to be just that it. They're going to say name another solution based on the given information. So if they give you this answer, you got to know that this answer is also going to be there. It could be that your answer is the square root of 7. So they tell you square root of 7 is a solution. You've got to know also that negative square root of 7 is another solution. So if 4i is a solution, then you got to know that negative 4i is a solution. And then if we have like negative 3 minus the square root of negative, because sometimes you get a problem like this and they're like, oh, if they're both negative, do I change both of the signs? No, you only change the sign that's in the middle or whatever's in front of the complex or the imaginary number. So the negative 3 is going to stay the same. The square root of 2 is going to stay the same. The only thing you change is that plus that would be there because, again, that's where it would be coming out of this part of finding it with the quadratic formula back here. Okay, and again, some of the homework questions, I'm going to make it that easy where it's, okay, here's one solution. Tell me what another solution is. And you just got to know to change the sign on whatever you're going for this part. All right, now they use that knowledge of this to then give you another question like with example 1, but now with example 2, they're going to give you the same thing, but they're going to give you a complex or imaginary solution. We'll make this as short as we can with the directions here. So basically, we're going to write an equation. Given the solutions, let's go with negative 4 and 2i. Okay, so we know we've got those two solutions. But again, this is kind of this thing back up here, like we had 4i, that if you've got 4i as a solution, negative 4i is also a solution. So for this one, if we've got x equals 2i, you also have to know that x equals negative 2i is also a solution. All right, so then we need to make these equal to 0. So we'll add this 4 to both sides. So now we got x plus 4. This one we will subtract the 2i. And this one we would add the 2i. All right, and then we need to multiply those three things together. Okay, so we're going to do the full method twice, basically is what it comes up on this one. Now, one big kind of hint, one big help for this one. You can put this on the side because this will be something. If you don't do this, you're going to make your life very miserable on these kind of questions. Basically, you want to multiply or use full the radical or complex numbers first. Because now you can not do that. You could do x you could do the full method here first, but if you do that, it's going to get really ugly really quick, and you're going to have I terms all over the place, and it's just going to be a big old nasty mess. So when you do the full method on these, do the full method on these two things first, because when you do that, it's going to look a whole lot better when you do that part of it. Okay, so let's do that. So we're going to do x minus 2i times x plus 2i first. So we've got x times x for x squared. X times 2i is 2ix. And where you put the variables, the i's and the x's in this case, it doesn't really matter, because here's the great thing. As soon as you multiply these two together, you've got a negative 2ix and a negative 4. Okay, now here's where, just again, you got to kind of go back in your Wayback Machine. If you do I times I, that is going to be I squared. So you got two really good things about this one by doing the imaginary or the complex numbers first for this one. You've got plus 2 minus 2. Well, that goes to 0, so these two things just cancel out. So we've got x squared. And remember, if you multiply and you get I squared, that's the same thing as negative 1. So that's negative 4 times negative 1. So it's just a positive 4. So when you multiply these two imaginary complex numbers together, it actually comes out really nice and neat, because now it's just x squared plus 4. And we still got to drop down this x plus 4 that was here. And now all the imaginary numbers are gone. All we've got left over is all whole numbers, all real numbers. And so now it's a lot easier when you go back and do the full method on this one, because there are no complex numbers. There's no imaginary numbers. There's no nothing. It's just plain old regular numbers to go from there. So now we've got x times x squared for x to the third. We've got x times 4 for 4x. We've got 4 times x squared for 4x squared, and then 4 times 4 for 16. All right, and if they don't say anything at all about writing it in descending order, that answer would be okay. So that answer should be fine. They probably would rather you write it in descending order, put it back in standard form. So if you do that, then that would be the answer that we're looking for there. But again, I think probably they would probably take either answer in that case, and it'd be fine. Okay, so that's a really good practice to go back to the imaginary numbers, because it makes you do the full method. It makes you do everything we were doing back in the early part. And again, that was everything we were doing back before fall break, and going through everything on that part of it. So it makes you go back and kind of redo everything we were doing with operations and the multiplying and just pulling everything together to get all that stuff there. Okay, so that's what was in the homework that we didn't get to. So that was basically should take care of everything that was the missing questions there. So that's why, again, we just didn't want to do too much yesterday, so we kind of let that hang on for that part today. The rest of what we've got to do today is maybe not quite as bad. We'll see. Still got to do a little factoring. So again, we're back in the factoring mode for some of this. So we're not going to quite get away from that one just yet. Okay, and this is kind of dealing a little bit, it's graphs, but it's still doing zeros. So it's a little bit of everything kind of mixed in with this one. So it's just a little bit of everything kind of thrown at you here. Okay, and remember, when we're talking about zeros, we're still talking about roots. Sometimes they'll call it roots. We can call them solutions. If we're graphing these are the x-intercepts. There's all kinds of different things they can call these, so it just kind of depends on what we're talking about at this point in time. You'll see zeros, you see roots kind of mixed in. And again, if we're talking about on a graph, then we're talking about x-intercepts. Occasionally they'll call them solutions. Sometimes they just call it answers. So there's all kinds of different ways they can call these things. Okay, now here's something that when we start graphing these, because we got a couple, we got this, and we got a little bit more graphing we're going to do tomorrow. And this is where we're kind of tying all this parts up together. That with multiplicity of zeros, the big thing that helps with this when we start graphing these is that the multiplicity of zeros is based on the powers of whatever equation it is that you're working with, but it's got to be in factored form. So we would be taking an expression, that we had before, and basically it's saying that if we get it back to this point here, we've taken this equation again. Well, this was all backwards, but we took this equation we had here and we factored it out, and we got down to this one. We're looking at what powers we'd have here. Now these wouldn't have powers, but they would all basically be understood to be the first power. And that's kind of what this is saying, is that when you break this thing down and you factor as much as you can, you look at the powers. If you have an odd multiplicity, so again, when they're talking about multiplicity, just think powers. Now, and all this, we're going to be talking about what happens on the graph. So the graph at that point, or the graph at that root, that solution, that x-intercept, whatever you want to call it there. It's going to cross through the x-axis. So again, if you have an odd power or an odd multiplicity, you're going to cross through. And right now, that's not going to mean a whole lot until you see it in a second, and then we'll actually show you what that means when we start looking at the graph and kind of figure out what's going to happen with it. All right, so you have an even multiplicity. Or again, if we have an even power. Then the graph turns around at that root or that x-intercept or that solution or whatever they want to call it at that point. But the main thing is that it gets to that zero, that solution on the graph, and it's going to turn around. Okay, so again, zeros, roots, solutions, x-intercepts, it's all the same thing. It just changes depending on where they're talking about it, if it's on a graph, if it's on an equation, expression, whatever it is that we're doing on that part. But it's still basically the same thing for this one. And then one other minor little detail that you have on these that we're not going to really worry about, but just in case they throw it at you, a relative maximum. That's any peak in the graph. And a relative minimum, well, that's any valley, any trough, I guess you'd say it, any low point that's in the graph. Okay, so we're going to do like 4 things with this graph, but they're all kind of all related for this thing. First thing is we're going to solve it. So we're going to have x plus 3 and x minus 4 squared equals 0. We're going to state the multiplicity. Has everybody seen the movie Megamind before? This is where we get a cartoon reference for the day. If you remember Megamind when he was in Metrocity, as he liked to call it, it was actually Metro City. He kept, and that's how the bad guy knew that it was not, who he knew it wasn't. Was it Metro Man? Whatever. Who's the hero?
Metro Man.
Metro Man. Yeah, Metro Man. That's how he knew it wasn't him because he called it Metrocity and not Metro City. Same thing with this one. This is kind of the opposite. This is multiplicity. It's not multiply city. It's multiplicity. As you're going through this thing. So we're going to state the multiplicity of each root. All right, we're going to go way back on this one. We're going to determine the end behavior. And this is going to take us back probably a week and a half before fall break. And we're going to sketch the graph. Okay, so the first part's going to be really easy on this one because if you have to solve this thing, we're just going to take x plus 3, set equals 0. We're going to take x minus 4, set equals 0. Okay, so solution-wise, really quick, really easy. That's x equals -3. That's x equals positive 4. So if you've got to find the solutions, really quick, really easy, just take each parentheses and set equals 0. So that part should be really simple. All right, so for the B part, the multiplicity. And a lot of times you'll see me on these, I'll just put MULT with a period for short just because it speeds things up. This is the power that you've got on each parentheses. So in this case, this is x plus 3. Technically, it's to the first power. So x equals -3 has a multiplicity of 1. X equals 4 has a multiplicity of 2. Okay, now in that you don't really do a whole lot with the numbers. They may ask you to kind of list, sometimes it may be some questions where it may just kind of, stop here. It may just ask you to do that, or sometimes it may even stop there. It may just say solve this thing and state the multiplicity of each root. If you get ready to graph this, though, the main thing you've got to know with this part when we start sketching this one is that when you get this solution, because this is odd, that means we're going to cross through. And again, we're going back to this part up here. If it's an odd power or odd multiplicity, we're going to cross through. If it's an even power, then we're going to turn around. And I know right now you're probably thinking, what do you mean? And again, we'll get there in just a second. We got to get one last thing, and then we can put this out. Okay, now the end behavior. If it's in factored form like this one, you're going to have to work a little bit to figure out what the end behavior is going to be. Because if we do this thing, and it kind of goes on the powers for this one, we've got x plus 3 times x minus 4 squared. If that was written like this, it would be really easy to figure out what the end behavior is, right? Because if it was one like this, you go back to your leading term, this would be a positive, and then x to an odd power. If you go back and check your list, that would have had this one where the right side would have been up and the left side would have been down. When it's written out like this, basically we've got to make it so that we look at this part of it. But the good thing is we don't need to worry about everything back here. We just need to know what this first term is. So what happens if we do x times x times x? Leading term would be x to the third, right? So if our leading term is just going to be x to the third, well, then that's what we said just a minute ago. The right side is going to be up, and the left side is going to be down. So if it's written in factored form, you've got to figure out what that first leading term would be, which means you get to ignore all the numbers. You just do x times x times x and figure out what that power is going to be there. All right, now here's the question. So to do that, we're going to take the solutions we've got that's here. We've got, basically, we're going to make just a quick number line. One, two, three, four. All right, so just make a quick XY axis for everything that's here, and we'll show you what we got to do. Because probably some of the questions on the test will be multiple choice just because it's going to be easier. There might be one of these that might make you feel, because again, you're working with a partner on this test. There's probably one of these questions that you may have to do by hand and you have to fill everything in, but a lot of these questions will be multiple choice just because we can get to a lot of them quicker, just based on what you know. So for this one, we've got solutions at -3 and +4. All right, here's where we're going back again, back in our Wayback Machine. This is where you use your end behavior. And we said the end behavior back here was that the right side was going to be up and the left side was down. So what you have to do is, if from this very right-hand zero, everything from this side of the graph is going to go up. You go to your very leftmost zero or your solution you got, and from there, everything goes down. And that's something we talked about it back before fall break. This is where we actually start tying this thing together. So once you've got your solutions put on there, whatever the rightmost tells you to do on that part, from there you do that. This case was up. You go to your left zero and you go down. Everything in the middle is now based on this part of this one. So this one says that when you get to -3, because the multiplicity is 1, you're going to go ahead and cross through. So for this graph, you get to go ahead and cross on through to the other side. But at x equals 4, it's an even multiplicity. And if it's even, it tells you got to turn around. So once you get here, once you hit the solution, you're not going to cross through. You're going to turn around and head back in this direction. And eventually, these two things will start to chase together and meet somewhere up here. Somewhere. Now, for what we have, just from the based on what we have for the time for this one, we're not going to figure out exactly what this point is. We just need to know that it's going in the correct general direction. Because I think if we actually started to chase this thing down, I think this number winds up hitting at like 48 up here. So if we had this thing to scale, this would be like 12, 24, 36, 40. But we're not going to worry about that. The main thing is that you've got the general direction going. We can always go back and just plug in numbers and eventually get this graph correct. So for this one, all I'm worried about is you've got your solutions. And then from there, you figure out what the graph is going to do, whether it turns around or crosses through, and what happens on your endpoints there. Which means, again, for a lot of these questions in the homework, these are going to be multiple choice questions because it's impossible to put that graph and make you do it by hand on the homework, so everything will be multiple choice. So you've got to know, what it's going to be. Because again, basically you can give you 4 questions where this one's up and this one's down, and this thing would turn around here and then cross through here. You can have these flip flops. So there's all kinds of ways you can do this with the solutions that's there to make it work out. Okay, so if it's factoring, finding the solutions is easy. It's some of the other stuff that's a little bit more difficult. Let's give you one more here real quick before we run out of time. Give you one more that's got this time written out not in factored form, so we got to get it in factored form. Okay, so the very first thing is we got to make it equal to 0. So let's get rid of this 5x to the 4th, move it back over here, and let's go ahead and do 2 things at one time here. Let's go ahead and add this 2x to the 3rd over here to make that 0, and then add the 2x to the third right there. So it's x to the 5th minus 5x to the 4th plus 6x to the 3rd equals 0. All right, now here's where this one is a little bit easier than the last one, because the end behavior is really easy on this one. It's already written out in standard form. We've got x to the 5th, and based on that leading term we've got here, it's a positive, and it's x to an odd power. So that one's going to be just like the last one, that your right side is going to be up and your left side is going to be down. Okay, so we've got our leading term. Now you've got to factor this thing. So we've got x to the 5th, x to the 4th, x to the 3rd. Hopefully, first thing you should do is take out an x to the 3rd. That'll leave you with an x squared, a 5x to the 1st. And when you take out the x to the 3rd for that one, that just goes back and it's all gone. So now we're here. Okay, factor-wise, this one should be a lot easier than one of the last ones we were looking at, because it's just the factors of positive 6, where the sum is going to equal -5. Be careful with your signs, because you can use 1 and 6 and get 5. You can use 2 and 3 and get 5. So it's all important on your signs for this one. B term is negative. If you do have a positive negative, they both have to be negative, which means it's going to have to be 2 and 3. Okay, so there it is in factored form. We've got x to the 3rd, x minus 2, x minus 3. So to solve those, again, we're just going to set that equal to 0. That's just x equals 0. Set that equal to 0. And set that equal to 0. So now we've got our 3 solutions here. All right, multiplicity, or the multiplicity, if you were in, atrocity. For your multiplicity, this one's x to the 3rd. So if they ask you for the multiplicity of 0, it's got a multiplicity of 3. If you're talking about x equals 2, that would basically be a multiplicity of 1, because there's no power there. Same thing for x to the 3rd, that would be a multiplicity of 1. So 0 has a multiplicity of 3. X equals 2 has a multiplicity of 1. X equals 3 has a multiplicity of 1. Okay, and then we can graph everything. And I hate to say that you're not overly concerned with your y-axis in this case, but you're not, because of what we're doing. We're not overly concerned, with our y-axis. We're more concerned about with the x-axis. All right, so this time we've got 3 solutions: 1 at 0, 1 at 2, and 1 at 3. And let's go back up a little bit. So this one, again, from the right 0, we're going to go up. From the left 0, we're going to go down. Okay, so that's what you need your end behavior for. The multiplicity, all the other factoring stuff, that's everything that's going to happen in between. And with all these are all odd numbers, which means that every single one of these is going to cross through. So this is going to go in this direction, this is going to go in that direction, and the only way to make these two things meet is that eventually this thing has got to turn. Again, we're going to cross through this one and head back up this way, and eventually somewhere or another it's going to turn and do something like that. And somebody's saying, well, how do you know this thing crossed through like this? How did you not know it didn't cross through like this? Well, and I'll back up for just a second. I'll put this back in here. That if we know that this graph is going this way and this one's going this way, because we know what's happening only with the ones and the threes here, if they got to cross through. If this is going this way, eventually it's got to get back to the next zero here. So somewhere it's got to turn back through. So it's got to go more like that and not like that. Same thing here. This one's going this way. Eventually it's got to get back here. Some point in time it's got to turn and come back that direction. Again, I'm not overly concerned with how high or how low this is going to go. It's just, is it going in the right direction? And that's the main thing we're looking for.